We'll pretend that we just started. Okay, yeah. So anyway, on this test, number 5 is identical to that one that we had, and I think that there was another one that was almost identical to one of the problems on the practice test. Um, so just be aware that I sometimes, especially with something this difficult, I might even completely reuse a problem that we've gone over already, just to give you another chance to get it right, or like down here, if you were practicing well, you would have gotten this one. I think this is the one, or maybe it's nearly the same. It looks so similar. But anyway, the rest of these, I don't know that there's anything in particular I'd like to go over as a group, other than to say that uh, it seems like if there's an issue, sometimes that issue is with the algebra. It's not with the calculus. You know how to do the calculus, hopefully by now. But the algebra is what's killing some of you. Maybe not killing you, but it's bringing your grade down a notch or two. So pay special attention to the algebra, and uh, that'll help you out, I think. Um, Also, I should mention, even though I don't want to like go over this in full here, that in my first class, where is it? Did I lose them? No, they're right here. In my first class, I had 3 students who successfully argued that they deserved 1.1. But 1 is 1 point, and it will result in a sticker upgrade for at least 2 of them. So if you think that I did you dirty and you should get another point, let me know. For example, you might wonder, how in the world would someone have a problem like this? Well, one example is if I took off, like on that first problem, see that first, each problem is worth 11 points. So this first problem is worth 11 points. But if on your paper I did something like this, -6, -6, I just took off more than 11 points, didn't I? So, if you see anything weird like that, I don't think I did anything like that, but you never know. Also, whoops, that's not what I wanted to do. If you find any mistakes, for example, if I marked it wrong, but it was just that you wrote it in a weird way and I just didn't understand what you were writing, come see me afterwards. I'm happy to listen to your arguments and pleas for mercy, and I might even agree with you. So do stick around after class if you need to, you know, if you need to ask me about any of this, or like maybe you're like, that's my answer to part A, but you had a different version of this, but it's basically the same. Anyway, um, I'm happy to listen to your cries, and maybe you'll even get a sticker upgrade too. I have these are just lying around up here. They're some of mine, but if you feel like you need a sticker, even though you didn't deserve one, you could have thumbs up, you know, even if you scored like a 75, thumbs up, maybe. Okay, well, anyway. So those are here for the taking if you want them. Okay, so with that said, let us move on. So this is a little bit of a weird day because we are we pick up the test and then what do we do with it? What I'd like to do is direct your attention to our webpage, and these have been floating around. They keep changing because I haven't been able to settle this, but now I finally got it. And so today what we're going to do is we're just going to sort of ease our way into techniques of integration. And so I'm going to help you through this particular thing, the pretest. If you have your computer, if you don't have it, it's okay, because you can do this on a piece of paper. But I'm going to help you through this. Let me explain, though, set the stage for this, why we're doing this. And that is that there are a bunch of techniques for integrating functions that are like substitution. Okay, most of you know substitution. Some of you demonstrated that you still need to learn substitution. It was number 2 on here. Please, please, if you're still fuzzy on your substitution, get unfuzzy, focus, get it working. Come see me. Oh, sorry, I'm out of order still. If on the exam you want to meet with me, please do set up an appointment to do that. I didn't reach out to any of you. even though a couple of you might be a little lower than I think you want to be, but you're not so low that I feel like I need to intervene if you don't want me to. In my statistics class, on the other hand, I've already set up appointments with 2 students. So there I'm gathering. So if like actually there's one person who may be, but anyway, if you feel like you're performing worse or you've got like this grade was way lower than you were hoping for, please do set up an appointment with me on my little web page thing, and I'm happy to meet with you at 6:30 in the morning. I could even meet with you at 3:30 in the afternoon, although I like 6:30 in the morning better. But anyway, that said, let's move on. So we have this thing. So what we're going to be doing is we're going to be learning about other techniques. So you have the technique of substitution that some of you still need to work on. In fact, we'll work on it some today. And then you'll notice coming up on Wednesday, so we'll be doing this tomorrow, we'll be doing a technique called integration by parts. It is sort of like substitution on steroids. So if you don't understand substitution, this is going to be you'll be totally lost. So please, please make sure you understand substitution before Wednesday or before tomorrow. But anyway, so we have integration by parts. We have trig integrals, heavily reliant on substitution there. Then next week, we have these are all integration techniques. Then you have trigonometric substitution. Right in its name, you have the word substitution. You got to know the substitution. I don't know why there's 2 things here. I'll figure it out. But partial fractions is a technique. So much fun, but also so painful if you don't understand algebra. So we'll work on that. Don't worry, it's super cool. And I think that does it for the techniques. So I don't know, this other strategies, maybe I'll push that to the next day. Because those are the 4: integration by parts, trig integrals, trig substitution, partial fractions. Those 4 are coming. And we need to have a solid understanding of basic integration before we hit all those. So that's why this thing has been out there. Some of you might have done it already. This pre-test module 3, techniques of integration, and the next one, which we'll talk about momentarily. So let's let this load here, and you can see it's something ridiculously long. But like I said, I'm going to help you through this. So give me a sec here. Can I make this bigger? I can, and I can do this. And I can zoom in. Okay, that's better. Okay, so we're starting out nice and easy. I hope we all know how to do this, right? Well, let's check. Adric, wait, is this randomized? Yeah, I think it is. No, it's not been, it's just alphabetized. Don't worry, Adric, we'll come back to you with a harder problem. That one's too easy, isn't it? Andrew, Andrew, you just got picked to do the easy one. You know the derivative of x to the 25th, don't you? I know, I'm putting you on the spot. Isn't that terrible? You've got all the pieces.
25,
You're doing it. Keep going. 25.
25x of 24.
Yeah, I heard the 24 somewhere in there, so I'm going to put it up there. Very nice. So derivatives, and you know why we're looking at derivatives. It's because integrals are the opposite of derivatives. That's one of the second fundamental theorem of calculus, says that the derivative and the integral are reverse, opposites of one another. So if you know how to do a derivative, you just do the opposite. Sorry, Andrew, I know you're thinking in terms of integrals, aren't you? Yeah. So, and I'm putting you on the spot. Terrible. Okay, I'm sure that's right, so I'm going to skip ahead. Oh, another derivative. So once again, if we understand derivatives, then we'll be able to do the opposite, which is an integral. Rachel, what rule? You don't have to tell me the whole thing here, but you know what the rule is called for doing this derivative? Oh, I'm sorry, I should have specified. Yes, it was Rachel J, not Rachel P. Rachel J, what is it called? It is the product rule. Does everyone know the product rule? See if you can jot it down, or maybe you're typing it in now, but it's the, I actually was going over this with Calc 1 last week, so we just did the product rule. But if you don't know the product rule, make sure you know it. It's the derivative of the first thing, which is 10x to the ninth, times the second thing, plus the derivative of the second thing. Oops, that's going to be a negative sign, times the first thing, x to the 10th. There it is. Or something like that. I don't care what order you have these in, as long as you got it all, because everything here is commutative, meaning you can switch it around. If you want to put the negative sign first and then the x to the 10th over here, fine, as long as you have the same pieces that I do. But that's the product rule. By the way, when we do integration by parts tomorrow, integration by parts is the opposite of the product rule. If you're following along on your computers with this, let me know if you're not sure how to deal with your version of this problem, because you probably have slightly different numbers. But product rule, simple, good. We've all got it. I'm not going to even bother checking. Here's another one, another derivative, another product rule. So let's see if we can rattle this off. I'll bet you can. Who's next? Max, do you know how to do the derivative of sine? What's the derivative of sine? Okay, let me type this in as we go. I'm just going to do this on the fly. So you do the derivative of the first thing times the second thing. And then, Max, do you know the derivative of tangent? Yes, secant squared. And I don't know how this particular thing would treat secant with the 2 up here. Probably it would do it right, but I'm scared, so I'm going to type it this way. Secant squared just means the secant quantity squared. Beautiful. Product rule. Do you know the product rule? Hopefully you do. Practice it if you need to. So that's easy enough. Ooh, whew. What about this thing? Where are we on our list of people? Oh, Rachel P. Rachel, do you know what rule you use for this thing? Doing the derivative. This is a fraction. There's another word for fraction that starts with Q. It's the quotient rule. Very good. Because this is a quotient, we're going to do the quotient rule. Let's do it. So the quotient rule, let me see if I remember. Low D high. Hold on a minute. Low 3 plus 2x times the derivative of the top, x, or e to the x, minus high d low, e to the x, times the derivative of the bottom, which is just 2. I should have made someone else do this, all over low low. 3 plus 2x squared. Is that right? Should I start submitting these? I think I probably should, just to make sure I'm doing them right. I guess I could always just do the key here. Ooh, theirs looks a little different than mine. Let's submit it to see that it's equivalent. Very nice. Should we submit all of these? Why not? It'll make me feel, doesn't it feel good to get that little green bar up there? Oh, it's so nice. Okay. Stop me if you have questions. Things are getting a little trickier now, aren't they? Maybe. All right, natural log. What do I do here? By the way, I'll even give you the name for this. This is called the chain rule. But natural log, what's the derivative of the natural log of x? So let's see if we've got that. Where am I? Oh, Drew. Drew, you know the derivative of natural log, don't you? Yeah, so it'd be 1 over all that mess. And then, of course, the chain rule says do 1 over all that and then multiply by the derivative of all of that stuff. So I'll just do 1 over x squared plus 10x plus 33. And then I multiply this by the derivative, 2x plus 10. Very nice. Yeah, why not? I'll just click submit just to make me, look at that, beautiful. Okay, finally, we get integrals. Now, some integrals, even though you should be using the substitution, some integrals are going to be easy enough that you could skip the substitution bit. This is one of them. Let me show you the trick in case you're not familiar with it. Give me a sec here. Pick this up here, and I will put this up on the screen. Maybe. There it is. Yes, there it is. Okay, so let me just show you this little trick that I use all the time. Is if you have e to the, how about a times x, ends up being 1 over a, e to the a times x plus c. So it kind of makes sense that if you were going to do the derivative of e to the ax, you would get a times e to the ax. Here it's just the opposite. You're doing 1 over a. So this is just a rule that you could do. You don't have to do this. You could use substitution if you want to. Just this is a time saver that you can use. We'll use it just a minute. There are two other rules that are similar to this. The antiderivative of cosine of a times x dx is 1 over a times the sine. And then the antiderivative of sine times ax is equal to 1 over a times the negative cosine. So I'll just put the negative out front. Something like that. In fact, you could do this with all the trig functions, but it's most likely that you'll be seeing things like this, this, or that. Ooh, you know what? I can make this even better. Even better, and here's how. Put a plus b up there, and it still works. Can I fix this? Just a minute. Slide these over just a bit. Check it out. Plus b, and then I got to slide this stuff over. Come on. So even if you have an ax plus b, you can still use this trick. So just a little time saver. You don't have to do it this way. If you prefer using substitution, please do. But let's switch back to this to see how we're going to do this on here. So I'll use that little trick to make things a little easier for myself. So I do 1 over negative 9 times e to the negative 9x. And look, they've been so kind. They put the plus c in there for you. Isn't that nice? So there it is. It's correct. What do they have? I'm curious. It's basically the same thing. Stop me if you have a question. We're getting into some more difficult territory here in just a minute. But, I didn't want you to look at this and say, 22 questions. Yeah, there are 22 questions here. Let's see. I'm going to skip over a few of these. Ooh, this one is so good. I'm not going to skip over it. Okay, sine of x. Let me jot this down. Some trigonometry here. Do you know your trigonometry? I don't know if you do or not. You might have just taken the trig test and gotten lucky, right? Some of you, you know who you are. Here we go. So let me write this down. I've got it written down. There it is. We're supposed to simplify this. Okay, well, this illustrates one of the best identities that exist. And if you know no other identity, I hope you know this one. So let me go ahead and simplify this. I'm going to factor out sine, and I'm left with cosine squared plus sine squared. Oh, the moment I see that, I hope that you have the same emotional reaction. I just get so excited. It's like this dopamine hit right up there. Cosine squared plus sine squared. I know that. Wait, what is it? It's 1. Isn't that beautiful? It's like you're taking all of these functions. I remember what it was like 40 years ago. I just realized so long ago. I remember learning about sines and cosines and realizing that this is like matter and antimatter. I can put these together and get rid of them. These things that caused me so much pain. All of a sudden, I get this jolt of pleasure to get rid of them both at the same time. Isn't that beautiful? Sine of x times 1 is just sine of x. Hopefully you have a similar emotional, maybe not quite so extreme as me. I guess I've been doing this for 40 years. And so perhaps it's the buildup of knowing that each of you gets happy maybe when you get to take something complicated and make it simple. I always get happy when I can simplify something. Ooh, there. Oh, okay, so this is the product to sum formulas. So this is going to be, I believe, 14x. This is a little bit more esoteric. Why is this on here? Okay, so we'll just use the product to sum formulas. I believe that this is going to be 14x here. You add the two. Wait, syntax incomplete.
You don't need the X.
What?
There's no X.
There's already, oh, there is already an x. And this one's going to be the difference. Let's see if I'm right about that. Okay, I do remember my sum to product and product to sum formulas. I don't know why that's on there. Oh, you know what? Now I do know, but I don't like it. So it's there. Yeah, okay, I know why this is on here. I guess you've got the same thing down there, product to sum. So do the same thing. This is going to be 14 times 1/2, which is 7, times the sine, quantity, sine of, add those together. 49 plus 13 is 59, 62. 62y plus the sine of, subtract them. So that's 49 minus 13 is 36. Is that right? 6y. There it is. Okay. Yeah, I guess, yeah, now I realize why this is on here, but like I said, I'm not thrilled, but anyway, that's the product to sum. So it's a good thing that I'm going through these in such detail. Okay, I'm not going to do this one for you because it's a straightforward substitution. Hopefully you see that you're going to let u equal sine of x and du is cosine of x dx. In fact, you could probably do this in your head. I've already done it in my head. The answer is 9/6 times the sine to the 6th power of x plus c. But make sure you do it yourselves. Do the substitution. I know you want to know, was I right? Of course I was right. 9/6 is the same as 3/2. Great. Okay, moving on. Oh, interesting. Can you complete the square? Let's do this. I know that's been a long time for you. I know, because you already had algebra back in 8th grade because you're all advanced students. So give me a sec. I will write this down. X squared plus 8x plus 9. Okay, so algebra. Do you know how to do algebra? I want to complete the square here. So what you do is you take half of this number times, I'm sorry, yeah, half of this number squared times 1/2, that looks like an x. 1/2 times that number, we'll call that number little b, and you square it. And that's what's going to go up here. So here's how this works. X squared plus 8x plus 1/2 of 8 is 4. 4 squared is 16. Now I can't just add 16 without balancing it, so I have to subtract off 16. And then there's that 9 that I had over there. Do you remember completing the square? You probably do now. It's probably one of those things that it was painful enough that you blocked it from your memory. And if you went into counseling, you would be able to bring those memories back. But I'm trying my best to help you bring them back now. Because it was painful, wasn't it? Okay, so let's see. How does this shake out? I get x plus 4 quantity squared. That's what you get when you factor that. And this is going to be minus 7. So this stuff becomes that. Isn't that cool? Okay, maybe it's not that cool, but it's a useful technique. When we get to doing partial fractions, we're going to have to use this particular technique a little bit. So there you have it. Whew. Okay, what else we got? So that's easy enough here. We'll double check 4 and -7, just like what I had. Okay, this is basic trig. I'm not going to do this with you because you can do that yourselves. Ooh, quotient and remainder. Oh, this was fun, wasn't it? Yeah, let's take a look. How far are we into this? 14, good. So I didn't want this to take the whole period, but I knew it would take a while. That's why I kept pushing homeworks back. Okay, let's take a look at this. It's going to take me a minute to write this down. Okay. So I'm supposed to find a quotient and remainder. If you don't know what those words mean, I'm teaching you now, I guess. So here's what we do to find the quotient and remainder is we take the top thing and we're going to put that top thing underneath a division symbol. So there it is. See how quickly I wrote it? So that goes like this, and put the bottom thing over here. This is exactly what you did back in third grade when you learned long division. Did you learn? Just a minute. I need to know this. I want to know how badly our schools are failing us. Do you know that this is the same as this? Is this something that you're from? Okay, a few heads are nodding. Thank you. Even if you're just faking it, it makes me feel a little better. And you know how to do this long division, don't you? You do, okay, 13 goes into 24 once, and then you subtract and you get 11, and you drop this 2 down and you say, okay, how many times does 13 go into 112? I think it's 8 times. 8 times 13 is going to be 104. Yeah, and that leaves you 8. So that there is the quotient, and that's the remainder. And you used to write it like this maybe, that 242 over 13 is equal to 18 plus 8 over 13. Maybe this is jogging a little bit of memory. Maybe it's not. It is possible to, this is where, the quality of your elementary school teachers might be coming to light. And that is that it is possible to do these two things on a calculator and avoid all of this. But we need all of this to be able to do what I'm about to do. So anyway, there's quotient remainder back from elementary school. Now let's do it up here using algebra, which you might have learned in algebra class. And that is I've got this, I'm doing this division. And I ask myself, just like I do down here, how many times does 5x plus 3 go into this thing? So I just take the first bit, 5x times 2x cubed would equal 10x to the fourth. So really all I care about is that first term. And notice that 2x cubed times 5x is 10x to the fourth. Let me erase this little line I put here. I have to continue and multiply this by the 3 as well. And that'll be 6x cubed. Now, I am confident that even if you don't know how to do long division with numbers, that you can subtract numbers. And when I got here and I did 24 minus 13, that didn't confuse you too much. 24 minus 13 is 11. However, when you're dealing with expressions, algebraic expressions in particular, subtraction is a little harder to do. So let's see if we can talk through this. I'm going to subtract this stuff, and I don't care how you do it, as long as you're consistent. I am going to do it this way, where I just write the negative sign out front and put parentheses to remind me I'm subtracting all of this, so that 10x to the fourth minus 10x to the fourth is 0. Negative 14x to the third minus the positive 6x to the third is negative 20x to the third. So check it out, make sure that makes sense. The time that this really comes to bite you in the thigh, I don't know, can we say butt in this college? I think we can. Oh, I've just been recorded. This might be my last semester here. Okay, well anyway, getting back to this, it would be a blessing in disguise. I have grandchildren now and I need to go visit them more. But anyway, getting down here. Now the next thing you do, you drop this thing down, 32x squared. We're doing great. And then you ask yourself the same question we just did. How many times can you put 5x in negative 20x? What times negative 20x cubed is equal to 5x? What times 5x is equal to negative 20x cubed? My bad. So I'm going to multiply this by negative 4x squared. Negative 4x squared times 5x is negative 20x cubed. So far, so good. Now we do the same thing with the 4x times the 3. And I get negative 12x squared. I subtract those two, and I get 0. Here again, be super careful. You're subtracting a negative, which means you're adding. And negative 32 plus 12 is negative 20. If anything looks fishy, let me know now. So far, so good? Sure. I'm going to blow through this, though, because I think we're good now. So this is going to be times 4x. This will be negative 20x squared minus 12x. Subtract those. I get 0 minus 39x. Drop this 4 down here. Sorry, there we go. Negative 4. And then I have, how many times does 5x go into 39 is negative 7. Is that right? Each of the others, oh, yeah, the other ones came out evenly. This one will not. That's too bad. Well, that's the way it's going to be. So negative 7. So this is going to be minus 35x and then 21. Yep. Oh, you're right. Why am I unbelievable? Look at that. Thank you. That's going to simplify my life. I was going to, yeah, actually, and I shouldn't have just put a 7 up there anyway, even if it was 39. Yeah, that's going to be so much better. Negative 27 plus 12 is 15. Oh, yeah, minus 4. Okay, so that's going to be negative 3. Thank you. And that's going to be 3, 9. Okay. And this is going to be negative this. So this will be 5 at the end, isn't it? Is that right? 5? Okay, so here's the quotient, that nasty thing. This is the remainder. Wow, that was so much. You play around with it, you'll get it right eventually, hopefully. Quotient remainder, let's see if I got it right. Yay, I got it right, 5. Thank you, Claire, for finding my mistake. Okay, let me blow through. I'm running out of time. Okay, factoring. You can factor, can't you? Yes, you can. You can factor. You can do some factoring by grouping. You can factor. Sorry, I know. Okay, cubes. You can factor. Do you know how to factor the difference in sum of 2 cubes? Let's make sure. Let me write these down. So the other ones were pretty straightforward. This one you might not know or remember, so let me remind you. 27. Here is the sum of 2 cubes. You get, so this is going to be 2x to the third plus 3 to the third. So it's 2x plus 3 times 2x quantity squared plus 2x times 3. I'm sorry, that should be a minus. There, minus, thank you. Plus 3 squared. There we go. So anyway, that's the sum of 2 cubes. The difference of 2 cubes, if this was a minus, you would change that to a minus and that to a plus. But it's straightforward. You can do factoring. So you can see all of this stuff is just sort of a review. What are we already solved the equation? It's quadratic. I know it doesn't look it. Multiply, and you'll find out that this thing, oh, it's not even quadratic. This is linear. Multiply by 3x. Multiply everything by 3x. All of the denominators go away. It'll be easy. Solve a system. I hope you can do this. If not, you can come see me. Finally, something interesting. Oh, no, it's not interesting at all. This is substitution. It's a straightforward substitution. Let's see if I can do it in my head. Just a minute. 2/3 times, whoops, times 14 plus x cubed. Why do I have so many parentheses? To the 3 halves. Why so many parentheses? Okay, and then I have to multiply or divide the whole thing. Can I just divide the whole thing? I'm just going to divide the whole thing by 3. Let's see if I'm right. Yay, I got it right. Okay, I know, doing substitution in my head, but you can do it too. Some of you are like, yeah, that's super easy. But you shouldn't do it in your head if it's an exam or a quiz. What's this one? This one's also a substitution. Really straightforward, though. I'm sure you can do it. Okay, so that takes care of that stretch of questions. So you'll notice that there are actually 2 things to do on your homework for today or tomorrow. So the other thing is dealing with exponential equations. Why can't, oh yeah, here we go. I'll just do next. Yeah, whatever, leave page. Come on, next. Come on. Techniques, integrals, this one. Why won't it do this for me? What's going on? Just a minute, I have to force it to move on. Okay, the next one is, what in the world? It's like it will not allow me to leave the page. Yeah, you were just going to go nuclear. There we go, we're just going to start fresh. Okay, give me a sec here. Come on, Moodle. Okay, yeah, I'm shutting it down. Just a minute. I know it's probably the fact that I'm using Firefox and not Chrome. Better yet, I should use Safari. Here we go. Courses. Come on. Why is it not opening? Is Moodle broken? What is going? Okay, I'm going to Chrome. Oh, look. Do you know why these kids are all laughing here? You want to see? Where is it? Where's the view? Open image? Oh, now it opens. Oh, you'll never know then. Yeah, if you open that image in a different tab, you can see why they're all so happy. This is taking forever. Well, anyway, I'll just mention what you'll find is there's a second homework that's a little shorter, and it's all about exponential and logarithmic functions. So let me just go over briefly. This is stuff that you should have had before, but I'll go over, we'll forget about this. We'll go over the exponential and the logarithmic functions so that you remember what they are. Let's do this. Derivative of e to the x. Give me a sec here. I will write down the derivatives that I want to do. 2 to the x is equal to what? The derivative of the natural log of x. One more, as you might guess, is going to be the derivative of the log base 2 of x. Let's see if you remember all of these. I'll bet you do. Let's find where are we on the volunteer list? I think we're at Cooper. Cooper, do you know the derivative of e to the x? Very nice. That's our favorite function. You know, it used to be my favorite function. Back when I was learning calculus, I loved it. But now that I'm teaching calculus, I don't like it as much because it seems to cause more harm than it does good. But anyway, because it's kind of confusing the way it works because it's just its own derivative. Tyler, do you know the derivative of 2 to the x? Ooh, very nice. Yeah. So if you guessed 2 to the x, you're almost right. But it is 2 to the x times the natural log of 2. Beautiful. So that's the derivative of 2 to the x. Okay, next one. Sawyer, you know the derivative of natural log of x, don't you? It is 1 over x. Very good. Now, I'll bet you can guess when we get to it. And Caden is dying to tell me what the derivative of the log base 2 of x is. Take a guess. there's going to be a similar relationship. Okay, you said 1 over x. Very good. I know, I just can't hear very well. I'm just assuming that's what you said. And then you got to correct. You need something like that, don't you? Yeah, times the natural log of x. And since you said 1 over x times natural log of x, I have to assume that you're putting the natural log of x down here. And then that would be correct. So, very nice. Good job. So, yeah, so it's 1 over x natural log of 2 of x. The natural log of 2 is in the denominator for this one. Anyway, when you do the antiderivatives, so if Moodle ever worked for me, you would find that the antiderivative of e to the x is e to the x plus c. Easy enough, right? And then the antiderivative of 2 to the x is going to be 2 to the x over natural log of 2 plus c. Check it out. Over up there, since the derivative, you're multiplying by natural log of 2, you do the opposite when you do the antiderivative. And then when you get the antiderivative of 1 over x, ooh, this one's different though, isn't it? It's a little different. Matthew, do you know the antiderivative of 1 over x? It is natural log, but what symbol? Do you know what symbol goes around the x? Yes, it's the absolute value. And it's because the 1 over x is defined for both positive and negative x. And so for those negative numbers, you need to deal with them because 1 over x has a slope, or rather it has area. Whatever it has something. So the antiderivative ends up being the absolute value, natural log of the absolute value. That way the negative numbers are legal. You can put them in there. Oh, plus c. I lost a point. Okay, I got a point there. Okay, one more. The integral of 1 over x times natural log of 2. All right, any guesses? Mariah, do you know what the antiderivative of this is? It would be, I mean, it is, but this one, you're never going to do that except for this one time. And the reason why you're never going to do that is because this is the same as this. And you're just going to probably do this instead. That is the same as that up there. So this you never do. So anytime you have like a 1 over x, always just treat it as a natural log. Don't try to hunt out a log of 2 or something like that. I kind of led you to that particular answer by doing this up here so soon after, wherever it is. But in general, if you have 1 over x, don't do this. Pull the constant out and just do the integral of 1 over x, and you'll be in good shape. Okay, so like I said, the stuff for tomorrow, finally, the stuff for tomorrow is, click and then wait half an hour. The stuff for tomorrow is mainly just practice, review. Hopefully it won't be too bad, but if you get stuck on any of it, that's the time you need to come see me and or talk about it tomorrow. I will have a quiz. Oh, we never did this. Oh, look, finally. Guess that thing. Oh, yeah. I'll explain why this is here. So the tractor pull is a great example of variable work, or rather variable force. So there's like a sled here that a weight or a mass is pulled along. So as this tractor goes forward, the mass goes from the back to the front of this sled, and it drives this thing down into the ground so that when it's back here, there's not a lot of force, if you will. But when it gets up to this front of this sled, it's pressing down really hard, and it creates quite a bit of resistance. So a variable resistance, if you will, so variable force, similar to a spring, mass, whatever. It's a similar thing. So that's why I have that image there if you're curious. If you've been curious, That's what that represents, at least to me. Okay, so I've got a bunch of integrals here. This may have just been a waste for me to print this stuff up because now that I look at them, it's no different than what I have on the assignment for you. So what we'll do is tomorrow we will start in earnest the integration techniques for this course. So in the meantime, since we have 10 minutes left, I'm not going to make you do anything extra, but I do want to know if you do have issues or questions about your exam. Now is a great time to come and argue for a sticker upgrade or just for a sticker if you don't have one. Come on up and I'll do my best to either help you figure out what went wrong or give you that sticker upgrade. So thanks for coming. I'm going to stop this right here. And I will have a quiz tomorrow, but it'll be on the basics. You'll all get hundreds on it because it's just review.